There's been a lot of calculators already.
Yeah, a couple people have taken it. Now, word problems. All the word problem will do will provide us with a situation in which we try to solve the question. You have your notes package. So here. Okay, this is what we're doing here. Yes. So if you're done, okay, so a small bus can transport 12 students and a large bus can transport 24 students. In total, all the buses at a school can transport 780 students. There are 20 more small buses than there are large buses. Whew. So it says create a system of linear equations that can represent this. So we're talking about small buses and large buses. The first thing that we are going to decide is what variables we're going to use.
And then I'll learn about buses.
So I'm going to use the letter S for small buses and L for large buses. Okay? Now, there should be a way to create an equation basically with every sentence that they tell us information. All the buses at school can transport 780 students. So with that, I know that 780 would equal, well, every small bus does 12. So that makes sense that I could do 12 times S. And every large bus does 24. So this is our first equation that we can make. That 12 people times the number of small buses plus 24 people times the number of large buses, in total that makes 780. The next sentence, there are 20 more small buses than there are large buses. So I can make an equation there saying that if I take the small buses and I add 20 to them, it should equal, no, is that right? Does that make sense? No, not quite. Which one has more? Small buses or large buses? Small. So if I had this right now, which number would be bigger?
L plus 20.
It would be L plus 20 equals X. Because you have more small buses than large buses. Number 20.
Because there's 20 more small buses than there are large buses.
There's 20 more small buses.
So technically, in these questions, I would say the math is easy, but the English and reading is sometimes hard. What subject did you teach before you went?
The greatest one, English. Just saying it just made me shiver. English, yes.
Well, and
Be careful.
all right, okay. You should see. I want to make sure.
Okay, but wait.
I want to make shirts that say stuff like English is important,
Watch yourself.
but math is important.
Wow. So here's how I'm understanding this, okay?
All right. This is gonna be a good video.
You have a point guard, okay?
Uh-oh.
You have a point guard, and you have 12, no. Oh gosh. You have 12 point guards, plus 24 centers.
And together they weigh 780 kilograms.
Okay? But from what I understand, there are 20 more centers. What?
I just asked.
Am I totally wrong?
I was just asking if they wanted the YouTube video paused while you were going off on your rant here.
I don't believe you're lying.
No.
Tell me you're lying.
Nope.
Where's the camera?
There's no camera.
Audio?
Luckily, it's just audio only.
Okay.
So the only thing that could go wrong is if someone
I'm trying to speak.
if someone recognized your voice.
No worries. I'm trying to speak the language, okay? So now we got 20. Wait, so we have 20 more what? 20 more centers, right? So 20. Oh no. center plus 20. And what are we trying to find out? How many players there are?
Sure. Well, it depends what your 780 stands for. In yours.
780. Okay,
Because you
780.
said you had 12 point guards.
Yes.
So point guard can't stand for how many point guards?
No, it can't.
It could stand for,
So what does 12 stand for?
12 stands for how many students are in the small bus. The S stands for how many small buses you have.
You know what? I just like the reading part of it. I don't like the numbers, because it's just giving me a headache.
I can understand.
All right.
Still going.
All right.
That was great.
Okay.
We love that.
No, nobody learned anything from that. So that's an example of what not to do in this question.
Yeah.
Struggle with the reading, misinterpret the question. Those all make it more difficult. But we've got our two equations here. What would I probably use? I would use substitution because the S is already by itself. So I already have in equation 2, I already have the S by itself. So that means I could, in equation 1, rewrite equation 1, but instead of writing the S, I could write L plus 20. Now, I just have an equation just with L. The math is easy, I can distribute. So that'll be 12L plus 240 plus 24L. Put my like terms together. 36L on this side, subtract 240 from both sides. $440. Divide by 36 on both sides. And what does that come out to?
11.
11? I don't. 440 divide by 36. 12.2. Did we make a mistake somewhere? Oh, it's 540. There we go. I made a subtracting mistake. 540 divided by 36 is 15. So there are 15 large buses. How many small buses? 35. Because there are 20 more. Question?
Can you scroll back up to 8 for a second?
I can scroll back up to A. Is that far enough?
Yeah, thanks. That's okay.
And then part C says verify. Well, it's pretty easy to see that equation 2 works. I'm going to have to do a little bit of math, right? 35 times 12 plus 24 times 15. Type it in my calculator. It equals 780. So I can check to make sure that it works. So most likely the math is not what's hard in a question like this. It's the English that's hard. Now we have to be able to read the question and then interpret it and come up with an equation. Well, let's look at our next example. Everybody good?
So just for the verifying solution part, just say plug it in.
Yeah. We can just. I'm gonna plug in and check. I mean, obviously, on a test or a quiz, if it said to verify, you'd have to show that you plugged it in and show that it works. But that's a good strategy to use all the time. So another one, we're going to create a system of equation that represents this situation and define your variables. So sometimes if the question says define your variables, we have to create letters that we're going to use and say what they mean, even though sometimes it was obvious. Like last time I put the S above small bus and the L above large bus, but I didn't formally define the variables. To formally define it, I would probably go L is length, W is width. That would be defining my variables. Sometimes they even like you to start off by saying let L equal length and W equal width. Now we know what our variables are. The perimeter of a flag is 16 feet. So if you think about a flag, you see that that would have a width there, a width there, a length there, and a length there. So that first sentence would give us this equation. We have to use the sentence to see if we can make an equation with our variables. But since we have two variables, we would need two equations to solve it. The second part says the length is 2 feet longer than the width. Now, whenever they have a comparison, I start with them equal, and I say, okay, this isn't true. Which side should I add the 2 more to make it work? Which one's bigger, the length or the width? The length is bigger. So to make them equal, I would have to add the 2 to the width side. But sometimes if we just read it quickly and write on an equation without thinking about it, you might write length plus 2 equals width. So it's important to think about which one's bigger, and the length is bigger, so then I have to add 2 to the width side. And if this is equation 1, and this is equation 2, it would be really easy to use the substitution method. However, it's asking us to use the elimination method. So in the elimination method, this one is a little bit more work in the elimination method because my variables don't match up. So the first thing I'm going to do to equation number 2 is I'm going to subtract the W. Subtract W, so that my lengths, my widths, and my numbers at least match up. Then with the elimination technique, you have to have the same number in front of a variable, but one positive, one negative. Can you see that if you took equation number 2 and multiplied it by 2, the W's would both have 2's in front, one would be positive, one would be negative. So now I have to rewrite my equations one more time. So here's equation 1 is 2L plus 2W equals 16. And if I take equation 2 and I multiply everything by 2, I can now add the equations. 2L plus 2L is 4L. 2W minus 2W is 0. 16 plus 4 is 20. Divide both sides by 4. I would get L equals 5. W equals 3. And of course, you'd have to plug things in to verify. Can you do it as mental math though right now? Do both equations work with 5 and 3? Yes, they do. I can go back. Sorry.
Are we gonna finish it today or tomorrow? No way, man.
Yes.
It's gonna take the whole time.
It's not that long. We've done 2 examples already. Next ones are going to be quick. Has the contest sheet gone around to everyone? Check, have you got this yet? Okay. Okay, example number 3. So we want to create a system of linear equations that represents this situation and define your variables. Looks like they have a chart for us already. Calgary has a school that raised $195 by collecting 3,000 bottles and aluminum cans. The school received 5 cents per can and 20 cents per bottle. Right? This is different than Manitoba, where in Manitoba, if you collect bottles and cans, you get 0 cents and 0 cents, except if they're beer cans. But in other provinces give money for every single can for the recycling, as a way of maybe motivating people to recycle more. Okay, so anyways, what can we put in here? We know that the total amount raised total was $195. We know that, I can't fill in, amount of money raised per unit. I know that the cans are 5 cents and the bottles are 20 cents.
It says in dollars.
Does it say to do everything in dollars? Where?
Money raised per unit.
Oh,
That's odd.
point 0, yes, there's the dollar sign. 0.05 and 0.20. Thank you for noticing that. We don't know the number collected of cans. We don't know the number collected in bottles, but we know that there was 3,000 in total. Now, a couple things. This one is a little bit dangerous to put a number in. I'm just going to put an X through here, because you might be tempted to write 25 cents because it says total underneath, right? But if I do 25 cents times 3,000, it doesn't equal 195. It actually equals more. So something went wrong. The number collected, we don't know. So right now, I'm going to put a C here for cans and a B here for bottles. And then the amount of money you would raise would be 0.05 times C and 0.2 times by B. The chart is nice because the chart might help us make a system of equations. However, you might have been able to do it without the chart. So sometimes if a question doesn't give you a chart like this, you may or may not need to write it down. In other words, can you see from the chart that if we collected C cans and B bottles and there was 3,000 in total, can you see that equation 1, C plus B equals 3,000? Would you have needed a chart? Or could you have just read the question to figure that out? Okay. Equation number 2 is if you made $195 total and you got 5 cents for every can plus 20 cents for every bottle, that your total amount that you would get, this is the money from the cans, this is the money from the bottles, together added up will equal 195. Okay? So, solving using different methods, you could use substitution or elimination. If you use substitution, equation 1 is easy to get one of the letters by itself, either C or B. Then you would go to equation 2. And where the C is, you could substitute in 3,000 minus B. We're dealing with decimals. You'd have to distribute here. So I would now solve this. I would distribute this. I would get 150 plus 0.05B plus 0.2B equals 195. Subtract the 150 on both sides. Add my like terms. And get 0.25B is equal to 45. And go to your calculator, 45 divided by 0.25 is 180. Yes.
What could the 0.05 be negative?
Oh, thank you. Oh, so nice to notice that. At the end, when would we have found this otherwise? When we verified that it didn't work. This should be a minus sign. What does that do to change things? That changes this 0.2 minus 0.05 to 0.15. And then, if I now divide both sides by 0.15, 0.15, I get a different number for B. 45 divided by 0.15, 300. 300 bottles.
Write equations for one. Can you any equation?
You need a slope and a, yeah, you can have it in any form. So that would be fine if you wanted to leave it in that form. How many cans then? There was 3,000 in total? 2,700. We can do a check to see if this works. 300 times 0.2 plus 2,700 times 0.05, $195, this works. The elimination technique, you would have to figure out what you would need to multiply by to make one of your variables go away. Can you see that if you multiply 0.2, this is all I'm going to do. If you multiply 0.2 by 5, you would get 1. If you multiplied 0.2 by -5, you would get -1. And that would set you up for your elimination technique. But I'm going to leave that and not do it in the video. You can do the elimination technique on your own if you like. Was everybody done? Example number 3. All right. So now what I'm going to do for this question is I'm going to give you 1 minute to see if you can make the two systems of equations, just so that we're all on the same page for defining our variables. We're going to let K equal the number of kids and A equal the number of adults. So that's defining our variables. That way everybody's using the same variables All right, let's see how you did. If 2,200 people bought a ticket, the number of kids plus adults equals 2,200. And if 5,050 was earned, each kid is charged $1.50. Each adult is charged $4. There's your equation number 2.
I put equation number 2 as number 1.
It doesn't matter which you picked as 1 and which you picked as 2. Again, substitution works really nice because you can get either the K or the A really easy by itself. And now, if I rewrote equation 2, but instead of K, so there's rewriting equation 2, but instead of writing the K, I substitute in 2,200 minus A. $3,300 minus 1.5A plus 4A equals 5,050. Combine like terms, so I'm going to subtract. $3,300 on both sides. In these questions, so I'm going to divide by 2.5. 700. In these questions, there is a place where you can find out if you did something right or wrong easily by the answer. So in that last question, you know how I said we made a mistake and then I said we would find out when we verified? We would have actually found out earlier because in the last question, I would have got the number of bottles to be 12.2 or something with a decimal, right? If you got the number of adults in this question to be 653.7, 0.7 of an adult, what is that, a teenager? I don't know. I don't think that exists, right? And even if you took an adult and chopped off 30% of them, it's kind of like, they'd still be a whole person. Doesn't like chop off their leg and like you're not a whole person anymore. No, you're still a whole person. So, okay. If you got a decimal, in other words, you shouldn't start about, I guess you should, if you get a decimal, I'm hopeful that you realize that answer is not reasonable. Hopefully your mind didn't go where mine did about chopping people up or anything like that. That's not practical. So just realize that, yeah, probably did something wrong. Chop up people, you also have probably done something wrong. So at least we're learning some proper math and proper social skills at the same time. So if A is 700, that would tell me, how many kids would there be? 1,500. We would double check this to see if it works. Obviously it works with equation number 1, but 1.5 times 1,500 plus 4 times 700, 5,050, it works. What kind of concert would this have been? Definitely a kids' concert. When you have that many more kids than adults, and it's one of those kids' concerts where both adults probably don't want to go, and they decide, okay, you're taking our kids, not me. Only one adult goes and brings 2 kids, or something like that. Probably like Teletubbies or the Wiggles. I'm ashamed to say I have been to a Wiggles concert. Once. It was enough. I am not going back. You're going tomorrow? You got tickets? Nice. You're gonna be sporting the Wiggles 2023 tour with all the city names on the back in class tomorrow.
Yeah, it's gonna be fun.
Good time. Good time. This one's different in that they tell us something, and then you have to create the story. Create a situation that this makes sense. And define your variable. So, we have to, in defining the variable, say, let R equal number of rollerblade packs of 4, and I number of inline skates packs of 8. Those are like rollerblade skates.
Packs of what it says?
Rollerblade packs of 4 inline skates. What?
Really?
Yeah, maybe they sell them for only 1 skate in packs of 4, or you could get the double and get packs of 8. I don't know. Bigger wheels? Okay. So what's the storyline? What storyline could make equation 1 and equation 2? Total number of packs sold is
80.
80. Because if R is the number of rollerblade packs and I is the number of inline packs, okay? The total number of what sold? Wheels. And you guys are good at solving already, so we're going to skip that part. The hard part was creating the story.
You just do it.
You want to do it?
Just one time.
Just one
You got,
time?
like, some of those.
I'm going to take equation 2 and easily get R by itself. Then I'm going to take equation 1 and rewrite it, but instead of R, I'm going to write 80 minus I, which gives me 640 minus 8I plus 4I equals 440. I'm going to subtract 640 on both sides. Combine these alike terms, so I get negative 4I equals negative 200. Divide both sides by negative 4. I get I is equal to 50. And therefore R is equal to 30. plug it in to check. And it works. Oh my goodness. Is it true? Are we on the last question of the last booklet of the last unit of this course?
Wow. Here's the motion.
It's
What are we doing tomorrow?
well, tomorrow you have a quiz.
What are we doing on Tuesday?
Tuesday,
Wait,
we
Thursday.
are studying for our test on Wednesday.
Thursday.
Thursday, we are getting ready for our exam.
Getting ready for
What
everything.
is the day today? What am I-
It's Wednesday.
what am I
As they
doing?
said in the announcements,
Friday.
that I thought the announcements were very, very positive
What am I
today.
doing Thursday?
I think we should have more positive. Like they said, it's almost the end of the week. Now their math was a little bit off because we have completed Monday and Tuesday, and at the announcements you still had basically all of Wednesday, Thursday. We are not almost at the end of the week if you look at it mathematically. But I think what a positive way to live life. I think we should start going already on Monday. Start saying Monday, it's almost the weekend. And if you think about it that way, it'll be like, oh, this is awesome, it's almost the weekend. Like before you know it, it'll be the weekend, and the weekend will be over, and you'll be like, it's Monday. It's almost the weekend. And you just have a great time all the time. It's good. It's a good way to live. Being positive. You're struggling with that. You'd rather feel like it's like it's so far away from the weekend.
Yeah, almost the end of the year.
Almost
Yeah, 'cause you have to try to-
So.
almost second semester.
All right, here's one for you to try. Can you define the variables and write out your word problem for this question?
But this one, in the slope of the line, this equation, just find the slope.
Mhm.
Slope of the line.
Yeah, this is the line, and this is the equation of the line. And you have to find out the slope of that line. So you could graph that line, you could do whatever, like you could, whatever you want to do with that line, you can make a table of values, you need to figure out the slope of it. Okay. Me being regular would say the following. Let B equal number of bicycles and T equal number of tricycles. Okay? The question says we have to use those vehicles, so we have to use bicycles and tricycles. The total number of bicycles and tricycles is and then number of wheels is 100. There is my boring question. Now, my exciting question would be the following. Because it just says use these vehicles. It didn't say you had to use wheels, right? A collector of expensive bicycles and tricycles had all 40 of his collection stolen. Each bicycle was worth $2 million, and each tricycle,
What are we writing?
this is me being creative, was worth $3 million. If his collection was worth 100 million, these are nice bicycles. These are your parents, right? I don't know about you, but did you get the diamond studded pedals when you got your first tricycle? Probably no, right? Your parents probably didn't. They went to Walmart and they saw the $15 tricycle and the $3 million tricycle, and they opted for the $15 one. Right. So this question was worded originally to lead you into writing a question using wheels and bicycles, but being creative, it didn't say you had to use the wheels anywhere. It just said create a situation using these vehicles that could be modeled. So I got creative and instead made it with very expensive bicycles and tricycles. Do you see that it still makes the same equations? It would still make the same equations. You would still have the total number is 40. And now the first equation is in money instead of in wheels. And it's in millions of dollars rather than a $2 bicycle and a $3 tricycle. I think though it would be very hard, like, as much as it would be nice to have, well, it's not nice to see it. Okay. As much as it would be nice to acquire a $3 million tricycle, I think it would be very hard to sell that, even at 50% off. Like Kijiji app, great deal, 50% off retail. Buy my tricycle for $1.5 million. I'll even throw in the little bell ad. Ring, 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 ring. For food. Okay. All right. With that,